Today we're going to be completing a graded practice on Desmos called Proportions, Investigation, and Practice. The first problem we will solve together. The second problem is very similar to the first and is asking you to solve the problem using two of the different methods that we've learned so far. You can show your work on the sketch pad to the left. Number 3 is a matching problem. The questions are in the larger boxes and they have a letter by the name. The answers are in the smaller boxes with no letter. When I want to make a match, I want to match up one of the questions with one of the answers. If I click on a question, it'll make it bigger so I can read it a little easier. Once I've figured out what the answer to a question is, and I would suggest using some scratch paper or the sketch pad on problem 4. Once I've figured out what the answer is, I will take that answer, hover over the problem so that it highlights it in blue, and then drop it on top. Once I do that, it makes a match, and if I move it around by the gray bar on the top, they'll stick together. I can still click on one and take them apart if I need to, if I've changed my answer. Your goal is to complete at least 5 of these pairs with one problem and one answer. You can pick any of the 5 that you'd like. If you can complete extra for extra credit. Let's solve number 1 together. So it says that we need to solve this problem using 2 of the different methods that we've learned. All right. I'm going to use the number line that we learned about today and maybe a proportion. So John's planning to make a small garden in his backyard. He wants to plan out the design of his garden before he plants. If 2 inches on his design represent 5 meters in his garden, how many inches will he need to draw in order to represent his 16-meter garden? Okay, so if I'm going to use a number line, I'm going to start by drawing 2 lines. And I can use the line tool for that. Okay, they don't have to be perfect. And then I am going to label, all right? And I am going to label the top one as inches, so I'm going to put an I, and the bottom one is meters. You could do it either way, but you always must label. Labeling is the most important thing to remember to do. So before he starts, we would have 0 inches or 0 meters. His first representation of scale, they said that we would have 2 inches for 5 meters. So I'll have 2 inches for 5 meters. This is like multiplying times 1. This is the original times 1. Now each time I go up on each of my number lines, I'm going to multiply by the next size up. Okay? So I'm going to go up again, and I'm going to start with the original, and I'm going to multiply by 2. So this is going to be times 2. 2 times 2 is 4. 5 times 2 is 10. Still not at 16. So let's multiply by 3. Okay, so I'm going to go up some more, and I'm going to do the original times 3. So 2 times 3 is 6. 5 times 3 is 15. Ugh, still not there yet. Okay, so I need to go up at least one more, and we'll do times 4. So my original 2 times 4 is 8, and then 5 times 4 is 20. So here's an issue. I'm trying to solve for 16 meters. Meters is on the bottom, and 16 is going to be somewhere in between 15 and 20, probably somewhere around here. That also means it's somewhere in between 6 and 8. So if I know my answer is in between here, it's not one of these specific numbers, I know it's also between 6 and 8 inches. So using the number line method, it's hard for me to narrow it down to the exact amount. So because of that, I'm going to try using the proportion method as my second method. Okay? So I'm going to set up a proportion. You always start with your labels. I'm going to do inches and meters again, inches over meters. And this first ratio is with words or letters to let us know which is on top and which is on bottom. Then I'm going to set up two ratios equal to each other. Okay, so we already know that we'll have 2 meters or 2 inches on the top for every 5 meters. Now what we're trying to figure out is how many inches, so that will be represented with an X, an unknown value, will represent 16 meters. So I'll put a 16 down here. Okay. Now I can look to see if there's a pattern. How could I multiply or divide to get from 5 to 16? But I'm going to run into the same issue that I did before, where there's no perfect value or easy value that'll let me go from 5 to 16. If I multiply by 3, I get 15, or 4, I get 16. So I'm going to use the cross multiplication method, which I know works no matter what the value is. So you can always use cross multiplication to find a number, even if it's going to be difficult values. So you start by going with your diagonals, and the two numbers that you have, if you have one number and two numbers diagonally, two numbers you multiply together, right? So 2 times 16, and if you need to, you have a calculator over at the top. 2 times 16 is equal to 32. So I have 32. And then I'm going to look at my other diagonal. Let's look at the other. X times 5. It's cross multiplication because it makes a cross, or some people call it butterfly multiplication. Whatever number is across from X, this 5, I divide by that. Divide by 5. It's not going to be an equal number, which makes sense because we weren't getting an equal value for our number line. Okay, so I'm going to do 32 divided by 5. When I hit return, I get the answer of 6.4. Interesting feature in Desmos, if you ever want it as a fraction, you can click on the fraction button and it'll give it to you as a fraction too. It's really handy. So I know that my answer is going to be X equals 6.4, and we were solving on the top for inches, so it'll be 6.4 inches. Okay? So when I am trying to represent 16 meters, I would do so by 6.4 inches. Okay? Good luck. Remember, you need to solve the second problem using 2 methods by yourself and at least 5 matches for problem number 3.